Good morning, good afternoon, everyone. Welcome to today's Explorer Classroom event. My name is Joe Grabowski from National Geographic, and I'll be your host for today. If this is your first time tuning in this month, we are diving deep into extreme environments. We've been talking with scientists and explorers from all over the world who go to these places, research, bring back footage for us to see. Now, these extreme environments may be hard to get to. They may be locations where life is tough. But we've had a blast so far this month talking to our scientists and explorers and seeing some pretty amazing places. So we're pretty lucky today to be joined by George Kourounis. George is a Canadian adventurer and explorer. Now, George has been to many extreme places all over the world. George, I think you're up over 60 countries now. Does that sound about right?
About 75 now.
75 now? All right, I'm too low. So yeah, George takes things to the extreme. He's been things like chasing tornadoes and hurricanes and blizzards. He's been lowering himself into volcanoes, exploring crystal caves, paddling on lakes of acid. So George has pretty much done it all. He knows all about extreme environments. So we're always excited when we can steal some of George's time. So George, I'm not going to talk anymore. I'm going to let you take over for a little bit. And then we've got an awesome group of classrooms joining us from all across North America, and we're going to turn them loose with a little Q&A action when you're ready.
Awesome. This is so great. Thank you so much, Joe. Really appreciate it. Hey, everybody. As Joe mentioned, my name is George, and I'm an explorer, and I specialize in documenting the most extreme forces of nature all over the world. And basically, that could be any type of weather event, any type of geological event, erupting volcanoes, hurricanes. But what I really want to, I'm going to show you what we're going to talk about today. Sometimes it's better to show than to tell. So let me just pull up this here. Oh, I need to share my screen because that's how this works. If I go desktop, share, and then I go here. You guys seeing that? Yeah, all right. So literally traveling all over the world, sometimes with the National Geographic Society, sometimes for the Explorers Club, sometimes with the Royal Canadian Geographical Society. I host a lot of television programs as well. A fair amount of what I do involves volcanoes, which are one of my favorites. This particular image is from the Fogo volcano off the west coast of Africa in the Cape Verde Islands. And there I've got my special protective heat suit gathering some samples of this fresh lava as this lava flow comes pouring through or tumbling through this particular village that we were in. But also document hurricanes. They're the largest storms on planet Earth, these hurricanes that sometimes batter the Gulf Coast, the Caribbean. Of course, the Bahamas got hit very badly this year. But today, what I really want to talk about is tornadoes. So in terms of Earth's extremes, there are no more extreme winds than you get in a tornado. They are the most violent, the most damaging, the most destructive, and they happen really quickly. A storm can fire up, produce a tornado very quickly, and then the tornado just disappears. And I was just recently at National Geographic headquarters in Washington, D.C., and they've got a really cool device on display here, and I want to show it to you. Check it out.
Hey guys, today I'm at National Geographic headquarters in Washington, D.C., and today the lesson is going to be all about weather, natural disasters, and storms, stuff like that. And check this out. This is a photographic probe that was put into the path of a tornado in South Dakota. How cool is that? All right, you guys ready to learn some more? Let's go.
So we can study tornadoes sometimes by putting things in the path of them. And yes, it's very difficult. And yeah, it can be really dangerous to do this kind of thing. And this particular probe, it was named the Tin Man after the Tin Man character from The Wizard of Oz. And it had a bunch of different cameras, and it was placed in the path of an oncoming, very strong tornado. And some of the imagery that it caught was, well, it was an angle of a tornado that you would never want to see firsthand. That's why we put these probes and such in front of these cameras, or in front of these tornadoes, because they're so dangerous to try and get in front of them yourself. So here was the view from that camera probe, looking basically straight up the cylinder of this tornado. And you can see bits of debris flying around in the air around the tornado. So if you were standing really close to something like this, it would be very dangerous. But if you were to look up, you would get a view that looked something kind of like that. So we can learn a few things about tornadoes by documenting them visually. We also have some other methods of studying tornadoes, and I've been chasing them for about just over 20 years now, all over North America. And the storms that produce these tornadoes, they're a special type of thunderstorm. They're called supercell thunderstorms, and they can be gigantic, twice the height of Mount Everest, concentrating all of their energy on this tornado that's grinding up a farmer's field. And where do they occur most often? Well, the United States gets about 75% of the world's tornadoes, of all the tornadoes on planet Earth. Most of them happen in the central US, Texas, Oklahoma, Kansas, Nebraska, this area that we call Tornado Alley. We also get them in places like Indiana, Florida, spots like that, in the deep South, Mississippi, Alabama. And it's just the conditions, the weather conditions are just perfect. All of the different ingredients that you need, moisture from the Gulf of Mexico, that moist, humid air, you know, when you go out in the summertime and it's really hot and humid, that air is fuel for these tornadoes. And you need winds that sort of change direction as you go up high in the atmosphere, up where the airplanes fly. And that helps to put the spin on these storms to create these rotating winds. Now, I know we've got some Canadians here. Canada is not exempt from tornadoes. We get some up here, concentrated mainly in two places. Canada has two small tornado alleys as opposed to the United States, mainly in the prairie provinces, but also in southern Ontario, where I am right now. I'm coming to you from Toronto. And the area from Detroit and Windsor all the way up to Barrie, Ontario, is a spot where we get about 20 tornadoes every year. And over the past 20 years, I've probably witnessed somewhere in the ballpark of probably about 150 tornadoes, possibly, varying in size and shape. And basically, they're violently rotating columns of wind that are in contact with the ground. So these storms rotate, and that rotation, that spinning effect, kind of like flushing your toilet. The water in your toilet is very similar to the air above us in that it gets steered and spun into these vortices, this vortex of air. And instead of flushing something down, it's actually sucking stuff up like a giant vacuum cleaner. And so these tornadoes are capable of picking up large objects, vehicles, they can destroy houses, right? So at these wind speeds, these incredibly strong wind speeds, the wind actually starts to behave more like a solid as opposed to a gas. So if you get hit by these winds, it can be, you can find yourself in a lot of trouble. So this particular season in 2019, I was part of a research project called the Tornado Visualization and Doppler Radar Analysis Project. Now that's a really long name, but let me break it down for you as to what we were doing. So we were chasing these storms all over the central United States in places like Texas and Oklahoma and Kansas. And we would take visual observations that were time-stamped with the correct time and our GPS location, and then gather imagery. Like, for example, this particular storm was in West Texas back in the beginning of May. And there I am with the Dolan brothers, who were sort of the project mates on this particular research project. And we were carrying the flag of the Explorers Club. And so what we would do is document these storms, and then we would go and look at the radar data. So the National Weather Service and Environment Canada, they have these radar dishes that are capable of sending these radio waves out into the air. And the radio waves, they bounce off of objects like storms. And we can tell by receiving these radio waves back, these reflections coming back off of the storm, we can tell how big the storm is, which way it's moving. Is it increasing in size? Is it rotating? Kind of like how The police, they have their radar gun and they can measure how fast a car is driving so they can tell if you're speeding on the highway or not. That's exactly what we do with these storms. And we look at the imagery from these radar scans and we compare that with what we saw on the ground. And that tells us a whole lot, because when you're looking up at the storm, you can't see what's happening inside, but the radar beam can. So it gives us a bit of a three-dimensional idea, almost like an X-ray of the storm, that allows us to learn more about what's going on, because sometimes we don't know why one particular storm produces a tornado and another one doesn't. So by looking at this data, this special radar data, and then comparing with whether or not we're seeing a tornado at that particular time in that particular location, we can learn a whole lot. And this project sort of has been going on, ongoing for quite a few years now, and I've just gotten involved with it this year, and I hope to continue doing more research with these guys in the years to come, and giving presentations at conferences and things like that. But some of these tornadoes can be absolutely huge. The biggest tornado ever documented, I was there for it, it was 2.6 miles wide, and in metric, that's 4.3 kilometers. So absolutely huge. Some of them can be these slender, looking like an elephant trunk or a needle, but some of them are these gigantic wedges that just dominate the entire horizon. They can be absolutely humongous. And I find them quite beautiful, personally. Yes, they are destructive, but they only become destructive when they hit something, right? So we have a lot of these natural phenomena, hurricanes, tornadoes, but they only become natural disasters when they affect us as people, when they affect our towns, our cities, when they hit a farmhouse. In this particular picture, this tornado from South Dakota passed behind this little building and it didn't hit anything. So that was the kind of tornado that we like to see. We never want to see people's homes get destroyed by these tornadoes, but unfortunately it does happen. The more houses we build, the bigger our cities get, the bigger the targets are. Plus, the changing weather patterns. We're looking at a future that potentially holds more storms and possibly even more severe storms. So by studying these tornadoes and learning as much as we can about them, we can try and figure out what the behavior of this weather is going to be like in a year, in 5 years, in 10 years. Are we going to see more tornadoes? Are we going to see stronger hurricanes? And that's part of the ongoing research. And it's not just tornadoes. These supercell thunderstorms that produce tornadoes, they also create all kinds of other weather hazards as well. They can produce all kinds of flooding rains. They can produce lightning. I love watching lightning storms. They are absolutely beautiful. But these bolts of lightning are so powerful. Each bolt can have up to 100 million volts of power. It's amazing. You've only got 110 volts in your wall at home. It could be 100 million volts of electricity. It's like a giant static spark when you rub your feet across the carpet and touch a doorknob on a dry winter's day. And they can burn 5 times hotter than the surface of the sun. And when you see that flash and hear that boom you're hearing is the air exploding because it's expanding so quickly from that incredibly hot flash of electricity. And of course, light travels faster than sound, so you see the flash before you hear the boom. These supercell storms can also produce gigantic hailstones as well. So it's not just rain that comes out of these storms or these tornadoes. You can get these giant blocks of ice that can be very damaging. They can break windows, they can smash through roofs, especially these large ones. And I've had quite a few of my car windows smashed out by giant hail over the years. So how is our weather changing? Well, as we know, our climate is getting warmer, but what is climate compared to weather? Well, we sometimes say that climate is what you expect and weather is what you get. So for example, today I'm looking at my window right now and it's a clear blue sky, sunny day in Toronto. It's a little on the cool side, but that's normal for the fall, right? So that's today's weather. But if you were to average today's weather over dozens of years or hundreds of years, that gives us the climate, right? The weather that we expect to have at this time of year. And what's happening, of course, is our climate is warming. We know that's happening. But what we don't know is how these small changes in temperature are going to affect the weather specifically. Are these storms going to get bigger? Are we going to see more wildfires? Are we going to see stronger hurricanes, right? So we know quite a few things. Warmer oceans is more fuel for hurricanes. So we do expect stronger hurricanes. Warmer temperatures make for drier conditions in places like California, where they're having wildfires right now, these very damaging wildfires. But we're actually learning some other interesting things about tornadoes as well. We never knew about a connection between climate change and tornadoes. It was very difficult to try and figure that out. But some scientists last year actually, have finally figured out that there might be a relationship between the Arctic sea ice and tornadoes in North America. So it's amazing how something so far away can have an effect. And as the sea ice changes in the Arctic, it changes the wind patterns all over the world. And those wind patterns are one of the critical ingredients for creating tornadoes. So it's possible that changes in the Arctic, where the polar bears are living and they're hunting for seals on the sea ice, as that sea ice gets thinner and thinner and less of it, it can actually have an effect on whether there are tornadoes in places like Mississippi or Oklahoma or up in Canada. So our entire world really is connected, and small changes in one part of the world can have dramatic effects on the weather in other parts of the world. And so my job, my life is all about traveling to these extreme places, these places where the weather is the wildest, and then learning about it, studying it, documenting it, and then sharing it with people through television programs, through classroom visits, things like that. And so what I need your help. Teachers, grab a pen. So students out there, everyone in the interactive classrooms, everyone who's watching on the live stream on YouTube right now, I need your help as to where I should go next for my next exploration. So here's what I need you to do. I need you to send me some suggestions. I want you to tell me about what natural hazards happen in the places where you live, because there's so many students from so many places all over North America. Where you live, do you get tornadoes? Do you get blizzards? Do you get hailstorms? Do you get fires, floods, tornadoes, these kind of things? And what I'd like you to do is to tell me about it. Send me an email. Teachers, get your classrooms to send me some information about what happens in your part of the world and what you think might happen. So a lot of what I do is research. I have to study very deeply into what it is where I'm going and the different natural phenomena that I study. So I'm always looking for new ideas, and for you guys to give me a couple of ideas, I would really look forward to that. And you might be contributing to my next expedition out to document these extreme forces of nature. So take a bit of time, see what you can find out about the place where you live, and maybe learn a little bit about how the things that affect your area are contributed by different things that happen around the world. And there's my email right there, george@stormchaser.ca. So I'm really looking forward to getting some ideas from you guys. And maybe if I find myself in your town, I'll come visit your classroom as well. I think that would be a lot of fun. Let me just pull the video screen back up here. Oh, here we go. And stop sharing. There we go. Back on the video screen. Can you guys see me okay?
All right, we've got you back, George.
Awesome. I wanted to make sure I left a bunch of time for questions as well, because I'm sure you guys have a whole bunch of questions. We got lots of classes as well. So hit me up.
All right, perfect. Well, we're ready, George. That was awesome. Thank you so much for sharing not only your experiences chasing storms, but making that connection between the storms and our changing planet. I think that's so important. And I think you're right. We're definitely going to see more storms, more severe storms, and even storms happening in areas where we don't expect, or it's not usual. So I think we're going to see a lot.
And that's why I need everyone's help to help me out. I can't do this all myself.
All right. Well, I want to give a shout out to our classrooms joining us live on YouTube. I can see there's lots of classrooms there today. If you haven't already, use the chat sidebar on the right. Let me know where you're watching from. Send in some questions. And I'm going to give a couple shout outs right now. So Mrs. Sharage's class, 5th graders in Nebraska. Miss N's class in Georgetown. Looks like there's 100 students hanging out there. Mrs. Friend's 3rd graders in Michigan. We've got Miss Gio's 3rd graders in Tennessee. Mrs. Sutliff's 3rd graders in Colorado. We've got 5th graders at Brentwood Elementary. Oh my goodness, I don't want to miss anybody. Greenwich, Connecticut, we've got an ESL class. North Hollywood, California, Mr. Lee's class. Ontario, New York, Mrs. Johnson's group. So lots of classrooms. If I missed yours, don't worry, I'm going to come back and do another shout out to some of the classrooms we missed. But let's go to some of our live camera classrooms and get some of those questions. So we're going to go to Mrs. Thiessen's group. They're hanging out with us in British Columbia.
Nice.
Let me get that microphone turned on. Oops. Let's try that again. There it is.
All right.
How are we doing, boys and girls?
Yeah! Hey! All right. Introduce yourself. You got to speak loud. Go.
Why do you like to explore these kind of places?
Right. So why do I do it? So great question. I've always been interested in science and nature, even when I was your age. And as I got older, I started to get interested in travel and photography and even deeper into exploration. And it started off as a hobby for me, taking photos of lightning here in Toronto and such. And then it just kept getting bigger and bigger and bigger. And I eventually had to quit my job. I used to be an engineer and continue doing this all around the world. And now I've been fortunate enough to travel to places like Antarctica and Greenland, Australia, all over Africa, the South Pacific, North Korea, all over the world. So for me, I love watching nature at its most extreme, and I love sharing it with people so that they can experience what I see out there, because most people don't want to go to that trouble or danger to go and experience these, because it can be quite dangerous. But I've been doing it for enough years that I've been able to do it rather safely. So I do it so you don't have to.
All right, great question to get us started. And George, thank you for doing that for us. Okay, let's see. Let's go to the US this time. Let's visit Mrs. McBrien's group hanging out with us in Tennessee. Looks like some 4th graders. Let's get that microphone turned on.
Tennessee.
Let's try that again. Come on, Tennessee. There we go.
Hey, Tennessee.
Hi. All right, we have a student who'd like to ask a question. Erin, you want to come up here to the camera? Emmett, come on up. All right, you're going to get right in front of this camera, okay?
How do you survive inside of a volcano?
We've heard
All right.
about
Well, that's a great question. I do a lot of, including with the tornadoes and hurricanes, I do a lot of volcano expeditions as well. And they can be quite dangerous, as you might imagine. So I've got a special suit that I wear, which is made of a metal fabric, like an aluminum fabric. And it helps to protect me from the heat. And then I'll also wear a gas mask, which protects me from some of these poisonous gases that are produced by the volcanoes. So I've got all this safety equipment. And then I work with teams that are very, very experienced. So we have a bunch of people that are used to being around volcanoes, and we're able to read the behavior of the volcano and get a pretty good idea as to what it's doing and what it's going to be doing, right? So through experience, through study, and through knowledge, and through special safety equipment, I'm able to stay safe when I'm inside these volcanoes. However, sometimes I still have to get out of there because sometimes it gets a little too dangerous. And Tennessee gets tornadoes. Tennessee gets tornadoes usually in the early part of the year, in like March and April. So around that time of year, you guys watch the skies because they can happen. And you get a lot of trees in Tennessee. It's hard to see the sky sometimes.
All right, very cool. Great question. And George, I've got a video queued up of you looking very slick inside a volcano. So I'm going to play that really quickly so the classrooms can get a taste of what it looks like. So
Awesome.
bear with me for 1 second, boys and girls. Actually, let me pin my screen just to make sure.
I know which video this is.
I think you do. All right, it should come up now. There we go, and I'm gonna play it. Classrooms, you should see it now.
I'm explorer and adventurer George Kourounis, and when I explore, I do it by the seat of my pants.
All right, very cool. So let's come back from that screen share. It's a very snazzy suit. Doesn't look like it was too hard to get fitted for it though. It looks nice and loose, and
It's got to be loose to have all your safety gear, all your climbing harness, and everything else underneath it.
Yeah, that sounds fair. All right, so let's grab a question from YouTube. So, oh man, so many questions to choose from, but I should give a couple more shout outs. We've got second graders in St. Louis, Missouri, who are joining us. And there was one more group I wanted to make sure we got. Oh, Brentwood, Spokane, Washington are joining us. So coast to coast today, George, all across North America. Really cool. Okay, so we've got a classroom here who's wondering, what is the most impressive natural disaster or maybe phenomenon you've experienced and researched?
Wow, the most impressive. Ooh, I'm gonna say, wow, that's tricky, because what is impressive? Like impressive as in beautiful to watch, or impressive as in the power of nature, right? So let me see. Being in the middle of Hurricane Katrina, when it was making landfall in Mississippi, right near the border with Louisiana, it was so powerful. The winds were so strong for so long, and it created this widespread damage. It was hard to believe that wind could do that much damage. So it was impressive to me in that it was almost unbelievable how much power nature has until you're in the middle of it. And then you realize, oh, we're pretty small compared to some of these storms.
All right, we'll swing back to some of our live classrooms. This time we're going to go to Mrs. Trist's group. They're joining us in Canada. Looks like a mixed group of grades. Let's get their microphone turned on.
Where are you guys? What part of Canada?
Let me see. Their microphone's just not cooperating. Mrs. Trist, I know we had a little bit of audio fun to start. I might need you to unmute for me. It looks like you did. How's it going, boys and girls? Did you hear George's question? What part of Canada are you in?
We're in Northwestern Ontario, so right in between Winnipeg, Manitoba, and Thunder Bay. Driving. Place called Driving.
All right, very cool. We're ready for you.
Okay, Gabby has a question.
What is your favorite place you have visited?
Ooh, my favorite place. So the video that Joe just played a few minutes ago of me inside that volcano, it's on a small island in the South Pacific called Ambrum Island. And there are several volcanic craters there. And I've been on many expeditions there, about half a dozen different expeditions. And I've been able to go down inside these volcanoes numerous times, about a dozen times. And it's so beautiful. And the lava just keeps churning and bubbling 24 hours a day, 7 days a week. And it's hypnotic. I love going back there. And if you get the chance, there's an IMAX movie that's playing all over North America right now. It's called Volcanoes, The Fires of Creation. And if you get the opportunity to go see that IMAX movie, you'll see some of the footage that we shot at the bottom of this volcano on the big IMAX screen. And it is mind-blowing. It's amazing.
All right, awesome. Let's jump to another live classroom. This time we're going to go to Illinois. We've got Mrs. Morgan's group hanging out with us. Let me get their microphone turned on. There's two options here. Let's try this one. How are we doing, Miss Morgan's group?
We are good. How are you?
We're good.
Can you hear us?
We got you. We're ready when you are.
Okay. Someone do your question? Yeah. Gotta stand up and talk right here.
Do you sometimes get scared?
Yes, absolutely. Yes. These things can be very scary. And some people say to me, oh, George, you must be fearless. But no, that's not true. I get scared. And it's okay to be scared. These things are big and they can be dangerous. And so what I do is I use that fear. I try to understand that when I get afraid, that's an indication for me to do something about it, to check my safety equipment, to check in with my teammates, maybe to run, maybe to get out of there. So fear is actually not a bad thing for me to experience because it helps to keep me alive. So fear is good. It's okay to be afraid of something. And being brave is not about being without fear at all. If you have no fear, then to me, you are foolish. Being brave is about having fear about something, but doing it anyway and overcoming that fear. So that's what bravery is all about. And so yes, fear, I do experience it and I'm okay with it.
All right, I'm with you 100% on that, George. I've been diving for over 12 years now, and before every dive, I get butterflies in my stomach, and that makes sure that I check all my gear, check with my partner, and I think the day you lose that is not a good day. That means you're too relaxed and you're not taking things serious enough. So I think that's important.
Absolutely.
All right, where do we need to go? Mrs. Miles Group, I believe they're in Stafford, Connecticut. Your microphone's on. How are we doing, boys and girls?
Good.
There they are.
Have you ever been in a flood?
I've been in many floods. So flooding can happen in lots of different ways. During hurricanes, there was always going to be flooding because there's so much rain that comes in hurricanes. With these supercell storms that produce the tornadoes, they also can produce tremendous amounts of rain and flood the roads. So I've been in more floods than I can count. You can have flooding even when it isn't raining. If you live in a mountainous place like Colorado or Utah, and you're in a valley somewhere, and there's a lot of rain that falls up in the mountains, that water can come down the valley along the river and flood where you are, even if it's blue sky where you are. So that's a pretty amazing fact about floods. We call those flash floods.
All right. George, I got a question here, and I like the way they phrased it. So that's why I picked this one on YouTube. And they're wondering, when you're inside a volcano, and then in brackets, especially in your baked potato suit.
That's so perfect.
They're wondering, how do you document things? Do you have a camera? Do you take notes? How do you document when you're in an environment so hot like that?
Right, that's a great question. So the thermal protective suit that I wear, I only wear it when I get really close to the lava. So if you're standing back, maybe, I don't know, a few meters back, it's not so hot. So you can take the hood off and you can operate a camera. And I have melted a camera before from the lava, and I have lit my boots on fire from walking on lava. So it is extremely hot, but if you're careful, you can do it in the right way without your equipment getting destroyed. So sometimes I'll bring hammers and other tools for gathering samples. Sometimes I'll have a thermal imaging sensor or camera that I can use to determine how hot the lava is. Sometimes I just have regular cameras, or sometimes we have an IMAX camera. And of course, these are expensive tools and we don't want to get them wrecked. So what we do is we get as close as we can without jeopardizing the safety of the equipment and ourselves, of course. But every now and then it's nice to get up close to be able to get those samples. So you have the special protective equipment. Plus, we want to capture some of those visuals with a person in the frame, because that really makes it personal. If you have someone in the picture, you can tell how big the volcano is, because now you've got something there for scale to show you how big it is. And the only way to really do that sometimes is to wear the protective equipment.
All right, baked potato suit. Okay.
I've heard it called that many times.
Mrs. Reeves' class, Leamington, Ontario. Let me get your mic on. How are we doing, Leamington? Uh-oh.
We got you, Leamington?
Oh, they're right up front. Mrs. Reed, can you do me a quick favor? I see you and I know you can hear us. If you look at the mute button in the bottom left, there's a little arrow next to it. Try clicking on it and selecting a different microphone option. So right next to the mute, a tiny little arrow opens a menu, and see if there's a different option there. We gotcha.
Okay.
Perfect.
Hi, my name is Angelina, and my question is, have you ever collected rocks from the volcanoes?
Have I ever collected rocks from the volcanoes? Yes, absolutely. Do I have any right here on my desk? No, they're in the other room. No, I don't have any here. But yes, absolutely. That's one of the things that I do at every volcano that I visit. We collect the rocks, and there's a lot of things that we can learn from volcanic rocks. So think of it this way. The lava is just liquid rock, and when it cools, it forms, well, rocks. But that cooling process, it's actually freezing. So rocks are frozen lava, which is kind of a weird way of thinking about it. And when that lava freezes, we can learn things about the kinds of gases that are in the lava, the types of minerals that make up that lava. So every rock tells a story about that volcano, how old the rocks are, what's their chemical composition. So it's really important to gather some of these samples, and the best samples are the really fresh ones, the ones that are still liquid when you get them. Those are the best samples because they're not contaminated, they haven't been sitting around for a while, and you know exactly how old it is because we gathered it on Tuesday or Monday the 28th at 1:40 p.m. We know that's when we got that sample, so we know everything about that rock.
All right, great question and fast work on the microphone. I like it. Mrs. Quinn's group, they're joining us in Canada as well, grade 7 and 8 class. I'm going to turn your mic on, and then I think you're in Grand Erie, so let's get your microphone turned on. There it is. How are we doing, 7 8s?
Hey guys. Nice and loud.
What kind of schooling did you have to do to be able to do this?
I couldn't make that out.
What kind of schooling did you have to do to be able to do this?
Right. What kind of schooling? Great question. So when I went to university, when I studied in college, I studied engineering and I used to build recording studios. That was my job. And there's no explorer school. There's no class to teach you what I do. So what I had to do is learn all of it on my own. I had to learn how to be a photographer. I had to learn how to be a videographer. I had to learn how to climb and rappel into volcanoes. I had to learn so many different things. I had to learn about weather forecasting. So I spent a lot of time learning from experienced people, from mentors. I read a lot of books. I spent a lot of time on the internet researching and reading articles and studying and practicing my weather forecasting over and over again and learning about every volcano on planet Earth. So a lot of it came down to self-study. But interestingly, a lot of the studying that I did in my old career as an engineer helps me in what I do today because of my ability to troubleshoot. I learned how to troubleshoot problems as an engineer. And now I just apply it to what I'm doing now. So it was a very useful study, and I still use a lot of the lessons that I learned back then. But the vast majority I had to learn on my own because there's simply no such thing as explorer school.
All right, and George, I'm glad you brought that up. This is the theme that we hit on Explorer Classroom a lot, is that there's no right or wrong way to become a scientist or an explorer, a conservationist, an adventurer. Everybody's got a different story. And sometimes education isn't the important thing. It's being enthusiastic and passionate. And you can find yourself in all sorts of amazing situations. You might start studying one thing in science and end up doing something totally different.
Absolutely. That's the one thing that I have in abundance is enthusiasm. Yeah, I love doing this so much. I can't imagine not doing it. And I just find any way possible to learn and just build more skills. Absolutely.
All right. So one more question from YouTube. George, this is a classroom who's wondering, a two-parter. Have you ever chased a tornado in Nebraska? And do you have a favorite tornado, one that you always look back on or think about?
Yes, I've chased many tornadoes in Nebraska. I've seen lots of them there. Nebraska is one of my favorite places for chasing tornadoes. You get quite a few of them in the springtime, in May and June. But my favorite tornado, let me think. I don't think my favorite one was in Nebraska. Sorry, Nebraska. You get lots of them, but I think my favorite goes to Kansas. There were two different storms that I pursued in Kansas in 2 different years. And those storms produced upwards of 10 tornadoes from that one storm. And I remember one storm near Dodge City, Kansas in 2016. It was on my birthday, May 22nd, if I'm not mistaken. I think it was on my birthday. And there were 3 tornadoes on the ground at the same time. So that was amazing. I'd never seen that before.
All right, very cool. Well, George, what always seems to happen is time goes way too fast. There's still lots of questions. So I'm wondering if maybe Classroom 1, if they can tweet some questions your way later today.
Absolutely, yes. You can find me easily on Twitter. Send me some questions. I'm more than happy to try and answer as many of them as I can. And I want to remind you guys of my challenge from earlier today. Try and find out about what kind of extreme forces of nature happen in your neighborhood and how climate change might be affecting them, and let me know about it. So send me an email. Hopefully you guys all caught that email. George@stormchaser.ca. Thank you so much.
Perfect. Well, you can find George at George Kourounis on Twitter. Classrooms, thank you for your questions. You guys were awesome as per usual. Thanks to both our YouTube and our live classrooms. We hope to see some pictures on Twitter later today with the hashtag Explore Classroom and @NatGeoEducation. At 2:30, we're going live with Nizar Ibrahim. So he's a paleontologist working in the extreme environment in Morocco in the Saharan desert. So that should be pretty fun. And again, George, thanks so much for hanging out with us today. As always, it was a blast. So thanks so much.
Thanks, guys. Woo! Wow.
All right. You guys are always so good at that. You never let us down. Thanks again, everyone, for hanging out with Explore Classroom today. We'll see you next time.